Okay, let's do this little bonus problem for the chapter 6, the joint method. So in our example, we will take P1, it's equal to 6 kilonewton. 6 kilonewton. P2, it's equal to 9 kilonewton. H, it's equal to 6 meters. And all the D, it's 4 meters. 4 meters. And 4 meters. In your quiz, you all have different numbers. Okay, and so if we look at what we know so first, is there any zero force members? No, but there's some load at B and C. So what we know there is this one. I'll make it bigger. I know this one and this one, the only thing that we know right now. And here we have 1, 2, 3 unknown. 1, 2, 3 unknown. We have 3 unknown, but we are able to solve for EB if we want with the force on Y, and EC with the force. And oh, that's an option. So we are able to solve for EB and EC with the force on Y. So that's option 1. So do the joint B and joint C on Y. So sum of the forces on the Y, it's equal to 0. And we will find BE and CE. That's an option. Another option is to find the normal force. And let's do this way. Let's use the normal force first. So we will consider our truss. So let's draw that. Our truss as a rigid body. So we don't look at what we have inside. Okay. We just look like it's in a rigid body. And we have two external forces and we have two reactions, AX and AY. And we have a normal force there because it's a roller, so ND. Okay. So first, find the reaction. Okay. Because if we find like the Y there, we cannot find this one anyway. So we will need to find this one first. So find the reaction. If we do the sum of the moment, there's one that is easier. Sum of the forces on X is equal to 0. So we have X, Y, and the only force that we have is AX. So AX is equal to 0. Sum of the moment about A, it's equal to 0. So what we have? We have minus 4 times P1, minus 8 times P2, minus 12. So 4 plus 4 plus 4. Now it's minus plus 12 times ND because ND rotate in the positive direction about the point A. So plus 12 times ND, it's equal to 0. So we find that ND is equal to 4 times P1, it's 6 kilonewton, plus 8 times P2, that is 9 kilonewton, divided by 12. So ND, it's equal to 4 times 6 plus 8 times 9, divided by 12. 8 kilonewton. So this one is equal to 8 kilonewton. And if we do sum of the forces on the Y, it's equal to 0. We have AY minus P1 minus P2 plus 8, it's equal to 0. So AY, it's equal to P1, 6, plus P2, 9, minus 8. So AY, it's equal to 7 kilonewton. This one is equal to 7 kilonewton. Okay, so now that we know this one, so this one now is blue, and this one is blue, and there's no AX. We can pick joint A or joint D to solve for CD. And let's remove this one and DE. And we don't need the Now we will do joint by joint. We are not on the truss anymore. So which one we do first? Let's do D. Let's do the joint D. Soup. Joint D. So we are the joint D. There, we know that the vertical force from the reaction from the contact with the tower, it's 8 kilonewton. We have a force in, so that's FED, and we have a force in FCD, and this one needs to go down because this one is going up, and this one must go left because this one is going to the right. We have our axis X and Y, and you can tilt them if you want. Sometimes it's convenient, not here. And for the slope, so let's look at this triangle there. So this total distance there is 6, and this one is 6, so we have 45 degrees. And in your quiz, you all have different angles, so you need to find the angles or to use the slope. Okay, so which one are we doing first? X or Y? We will do Y first. So sum of the forces on Y is equal to 0. So we have minus FED. So Y sine 45 plus 8 is equal to 0. So FED is equal to 8 divided by sine 45. Take your time to write your first equation always, because just to avoid mistake with your cosine and sine, which one is applied. So 8 divided by sine 45. 11.3. So FED is equal to 11.3 kilonewton, and we guess the right direction. So let's draw it there. So it's going down. This one is going up, and it's 11.3 kilonewton. Now we need to find FCD. So we do sum of the forces on X, it's equal to 0. So we have FED cosine 45 degrees minus FCD, it's equal to 0. So FCD, it's equal to FED 11.3 cosine 45 degrees. So FCD should be 8 again. Yes, this one, cosine 45, we multiply by sine, it's 8. 8 kilonewton, and we get the right direction, so it's tension. So this one, and it's 8 kilonewton. Let's remove the little 6 there. Okay, so now I propose to do the point C, the joint C, because now we have two given force, the 8 and the 9, and we need to find this one and this one. Okay, so let me do it there so I can see this. Oops. So let's do the joint, say C, joint C. So this is my joint C. This is the 9. This is the 8. This is the 4 that we don't know. And this one. And this one is FEC. This one is FBC. And because this one is going down, this one is going up. And now, is this one going right or left? We don't know because this one is going left, this one is going right. So I will say that is in tension. Just because we need to say something. And this FEC, so this triangle there, this one is 6, this one is 2. Okay, so this little triangle is 6, 2, and the square root of 6 square plus 2 square is equal to the square root of 40. That you can also write 2 square roots of 10. But anyway, so that's my hypotenuse, the square root of 40. Let's do Y first, because on Y we just have FEC. So that's my axis, X and Y. Now I can move a little bit. Okay, let me see. Okay, I thought my screen was frozen. Okay, sum of the forces on Y is equal to 0. So we have plus FEC time, so this one, so times 6 divided by the square root of 40, the hypotenuse, minus this one, 9, it's equal to 0. So FEC is equal to 9 square root of 40 divided by 6. So FEC, and we get the right direction. So 9 square root of 40 divided by 6. 9.48, so 9.49 kilonewton. And that's the right direction, so it's tension. And sum of the forces on X, it's equal to 0. So we have minus FBC minus FEC, and that this complement, so that's the one that's parallel to 2, so times 2 divided by square root of 40. And on X we have plus 8, it's equal to 0. So FBC it's equal to 8 minus the FEC, that is 9.49 times 2 divided by square root of 40. So FBC it's equal to, I know you like parentheses and I don't, but I'm working on that. Okay, so 8 minus this number times 2 divided by square root of 40, and it's equal to 5, and it's plus, so it means that it is tension. We get the right direction. So this one is 5 and this one is 9.49. It's just right there, so I can add them to this graph. So this one going up, this one going down, and it's 9.49. This one going to the left, this one going to the right, and we found 4, right? We found 5. So that's 5 there. I know there's a lot of information there. Okay, so now we can use B with 2 unknown on this side, or we can use E because there's 2 unknown there. This one, I don't really like the joint E. There's all the forces have complement on X and Y. So let's do the joint B first. Okay, joint B. Let me make it smaller. Let's do the joint. So we did, that was 1, 2, 3, 4. So joint B. Okay, here we go. I know the force at B, that is 6. I know the force there, that is 5. And I don't know this one, and I don't know this one. This one must go up because this one is going down, and this one must go left because there's nothing going left. That is FBE, and that's FAB. And again, AB, BA, doesn't matter. What's matter is to state if it's tension or compression. And to write the right direction, but it's not the force going from A to B or force going from B to A. It's the force inside the member AB. Either way that you take it from A to B or from B to A. If you cut anywhere in the member, that's the same thing. It's a tension everywhere or a compression everywhere. I know you are used to AB, it's from A to B in physics, but it doesn't really make sense for the truss. Okay, we need some angles, so we are there, so that's a triangle. this triangle for FBE. It's again the 6, 2, and the square root of 40, and you can't see anything, I'm sorry. And X and Y, so that's this angle there. So that's half of the 4, so it's 2. This one is 6. Okay, so now let's solve for the joint B. Let's do force on Y first. That allows us to solve for FBE. So we have FBE times 6, so that this complement there, the vertical complement. So times 6 divided by square root of 40 minus 6, it's equal to 0. So FBE is equal to 6 divided by square root of 40. No, times square root of 40 divided by 6. So divided by 6 times square root of 40. So FBE is equal to the square root of 40. That is equal to 6.32 kilonewton, and it's pulling. So pulling is equal to tension. And if we do the sum of the forces on X, it's equal to 0. So we have minus FAB plus FBE. So that's this side. So times 2 divided by square root of 40. And plus 5 is equal to 0. So FAB is equal to 6.32. That's FEBE that we just found before. And 2 divided by square root of 40. Oh, and just one thing. If you find something negative there, keep it negative in the next equation. Otherwise, your direction of your arrow there will not mean anything. Okay. Plus 5. So FAB it's equal to the number that you just found before times 2 divided by the square root of 40 and plus 5. 7 kilonewton. This one is equal to 7. This one is equal to 6.32. Let's go back to our main truss there. Yeah, you can see my previous problem there. Okay. And let's add this. Okay. I just make the green because we don't see anything anymore. So this one is going to the left, this one is going to the right, and that's 7 kilonewton. And this one is going up, and this one is going down, and that's 6.32. Okay, so yeah, green, I see green is also something that I know, just there's so many things. I should maybe not. Let me use blue again. So now that's what we know. 7, this one up, this one down, and 6.32 for FBE. We have one left, that this one. Seriously, I prefer to use the joint A than the joint E with all these angles. So let's do the joint A for our last free body diagram. If I am able to smaller that, I think it begins crazy. Joint A, that's very easy, the joint A. Here we go. Here we go. It takes time, but so last one, 5 is the joint A, step 5. So I will make it bigger after we have the point A. We have a y that is equal to 7. We have this one that is equal to 7. And we have a force there that must go down and left. That is FAE that we are looking for. And that's the same angle than the beginning. So that's the big triangle. So that's the 45 degrees because it's so if you look there, we are in this triangle. Okay, and this one is 6 and this one is 6, so this one is 45 in this example. Okay, so let's solve for this joint. But I write so big. So we can solve with sum of the forces on the y is equal to 0. So we have minus FAE. Y it's sine 45 degrees plus 7, it's equal to 0. So FAE is equal to 7 divided by sine 45. So FAE is equal to 7 divided by sine 45. That is 9.899, so 9.90. 9.90 kilonewton. And it's compression because it's pushing on the particle, so the particle is pushing on the truss. Let's say joint 5. It's not joint 5, it's a joint A. So let's add that. We say 9.90 and it's compression. This one, yay. So this one is compression, and that's 9.90 kilonewton. Here we go. We have all our forces. So, and we can write again. So, which one is in compression? Which color do we use? Let's put so in orange, I will put my compression. Okay, so that this one, every time the arrow are pushing, this one pushing, and everything else. Oh, what's happened? Sorry. Where I am. There. So that it looks like that's the only two forces in compression. Yes, so this one, this member, and this member are in compression. And this is tension. So we have this one in tension, this one in tension, and this one, and this one. I just want to leave the arrow. So we have 1, 2, 3, 4, 5 in tension and 2 in compression. Yeah. So that's it for this problem. Let me just go back on all the steps that we have done together. That's a lot. I know that's a lot on my screen. I don't know if it's really fun to see this going up and down, but we find the reaction first. Okay, so we find the reaction first. After that, after finding the reaction, we did the joint D, that is this one. We did the joint C, that is this one. We did number 4, the joint B, this one. We did the joint A, that is this one. And we avoid the joint E. So that was, I think, a good strategy. Let me check all the answers. And here we go. Here we go. Yes, 11.3 and 9.90. Yeah, everything is correct. So that was the steps. So take your time, one step at a time. It's long. The joint method is long because we do one joint at a time. But at the end, we have all the forces everywhere in the truss. So if the question is find the forces in each member, sometimes the joint method is the method to use. If it's just in one member, anywhere in the truss, we will probably use the method of the section that we will see in the next chapter. So congratulations to have listened to this video up to the end. It's almost 25 minutes video. It's a long video, but I hope it was useful. Bye bye.